So today we'll learn about how to do docking using Chimera and AutoDock. For that, first you have to install a Chimera and AutoDock. Just type Chimera download in the browser. Just go to this website, download UCSF Chimera and download the version which suits you. Since I'm using Microsoft Windows, I'm just going with Microsoft Windows. Otherwise, you can go with, if you are using a Mac, you can go with here. Or if you are using a Linux, you can go with here. I'm just going with Windows. Just you have to agree the guidelines. Just click the start the download manually. Just save it where you want the file and just run the exe file. Okay, since I'm already installed, here I can show you. Since I'm already installed the Chimera latest version, so I'm not gonna install it. Okay. Second thing, you just need is AutoDock Vina. AutoDock Vina download. Regular download stage of AutoDock Vina. Here you can see that for Windows version, here simply click this for Windows version and download the MSI file and just install this after installing the Chimera so that it aligns together. Okay. Since I already installed AutoDock Vina, so I'm not going to install it again. Then you need to find a good PDB ID. PDB ID for your protein of interest. For that, you have to go to RCSB website. It's a protein data bank website. Just search your protein of interest. I'm just going with 7U JGO. So it's an estrogen receptor alpha ligand binding domain. Simply, it's an estrogen receptor. And in this PDB, it has good profile. Let me show it. And also it has a complex with this ligand on it. It also have an magnesium ion. Okay, just once you find the right PDB for you, just click it download over here, download files. Just click the legacy PDB format and download it. I'm already downloaded it. Just and I don't wanna download it again. Just I'm canceling. And you need to have your ligand. Okay, ligand is a chemical which you gonna dock it to the protein. For that, just go to the PubChem. Go to the PubChem and search any ligand of your interest. I'm just going with estrogen, since it's estrogen binding domain. Estradiol, it's another name of the estrogen. Just click it. And in the names and identifier, in the structures, you can get download the 3D structures in the format of STF format. So just download this. I'm gonna name this East. Okay. Save it. The file. So you download your protein and a ligand. Then you have to prepare your ligand and the protein in the Chimera app for docking purpose. Okay. Once you have downloaded the PDB, that is the protein and STF format of your ligand, just open this PDB file in the UCSF Chimera in which you have installed it. See here, this is my protein of interest, and I'm working with the chain A, so I only want chain A, so I'm gonna delete every other chains. So for that, you just have to go to the select and go to the chain. I just want chain A, so I'm going to delete chain B. Once you've selected, then go to the actions, atoms and bonds, and go simply delete it. Let's go to R1, let's go to the C, and I'm going to delete that also. Okay, so this is what we have here. So this is my protein of interest. I mean the chain of interest in the protein. Okay, anyway, here you can see the ligand over here. Yeah, here it's ligand. They just change the one. So here you can see the ligand over here. Then I just have to remove all the water molecules. Just go to select and select, go to the residues. Just select the HOH, that means water. So you have selected, so look, and okay, water is filtered, and you have to remove the bound element, that is a magnesium. I already told you, right? This one, they delete it. That also, you don't want that. Okay. Then, yeah, that's it. Then you have to remove this ligand also for doing docking with your own ligand of interest. Since it's a native one, you have to remove that. Before removing that, you can find. You just need to draw a grid box over here, because this is the active site. This is a site where in our ligand also has to act on. So let's go to the action. Before that, I'll just import my ligand to just go file and work on. Just go to the location where here this one is my ligand. I just downloaded it and named it as EST. So open it. Here you can see that the ligand is over here. Okay. Just you have to prepare. Let's go to the tools and start surface editing, structure editing. Just add hydrogen. Here it shows two groups, right? This one is our protein, this one is our ligand. Okay, this one is our ligand, this one is our protein. And we just want to add hydrogen and in both. So okay, click both. Just control and click this. So select the both and click OK. It shows it adds problem adding one hydrogen to atom. Okay, we'll just ignore it. So go to the tools and go to again surface point. Add charge. Okay. So if you are going to add charge, if any missing, just click OK. It shows that for the group 2, that is unknown one, this is our ligand. Don't need any charges. But by the way, the QYM native ligand has a charge of +1. Okay. So, read. After then, everything is mostly done. Yeah, it's done. Let's go to the tools, surface binding analysis, where you can find the dock prep. Okay, right? Okay, here you can simply just uncheck the right mode to file, because we don't want a mode to file here. So uncheck this, and one model has non-integral total charge. Just ignore this. Click OK. Okay. And shows the same. Okay. Next, we have to draw a grid box over the native ligand present here, and then we just simply dock it. Okay. First, for that you have to go to tools, and there you can find it AutoDock Vina. Once you have installed the AutoDock Vina, it is automatically you come over here in this option. In this one, just a receptor is defined correctly, and you have to change the ligand. The ligand is this one. this one. You need to definitely you need to draw a grid box over the help of the proportion of the ligand here. Just draw that. Just simply enter any number, so you can get a grid box over here. It's going with the 10. Okay. Then once you change the control button 1, that means you can resize it by clicking control. Just I'm showing like this. You can just move it to the ligand. Okay. Make sure you place correctly on the ligand. It takes you, since it is in 3D, your vision is 2D. So just don't get confused. Anyway, it's good. The greater the size of the grid box, the longer time it takes to find a good course. Okay. So this is this box. Within this box, our ligand will find its good position. Okay. Let's go to that side. Here you just make note of this one. So, it is an active site for your ligand, for your protein here. So once if you want to dock another molecule, you just don't want to create take this much time to create a grid box over here. Just note this number and just place it here. And in the executable allocation, you have to locate the Vina file where you have installed it. I just installed it in the tools. There's a Vina, and you just have to locate the Vina exe file. Okay, the out file, just locate where you want the output file to be. So I want my output file to be in the, you can type out the messy part. Okay, it will be for video. Okay, I just want here. I'm just gonna name my file as EST and the protein name sound UKO. Okay. So this is my output file name. This is output location. My output location was set. Everything was good. Okay. After this, what we have to do is just click OK. Then it will run the molecular docking process, and you will get a result of. I'll show you in that. Okay. So here it's running there, right? You can see here it's running. So for me, only one model came. Pardon me, just did a mistake. I just forgot to delete the native one. Just again, I'm gonna dock again. AutoDock Vina, click after Vina. Since I developed the grid box, after developing this grid box, you have to just delete the native ligand. Okay, just go to the select and go to the residue. Here you see this one is your native ligand. How can you confirm it is a native ligand? Just go to the website. Here you can see it names is written as QIM. So most of cases it's same here. We'll go to the select and go to the chain. No, go to the residue and just select the QIM and go to the action. Simply delete it. All set here. Just click through. We just downloaded our PDB. We just got our ligand here, and we just docked up both ligand and the receptor, and then we just deleted the native ligand present here. Okay. then we have to do a docking. For that, just go to Tools, System, and just go to the AutoDock Vina. Okay, here just click OK. Then it's running. It's the docking process is running. Yeah, here we got around 1, 2, 3, 4, 5, 6, 7 models. The first model is the most stable one because of it has a less potential energy. The lesser the potential is, the greater the stability of the complex. And we got the 9.7, 9.6, 9.5, 9.8. Just remember this name. Chimera model 3.1. Okay. So what will you do now? This is your result. If you want to document it, just take a screenshot or anything. Let's go to the results file over here. So here you can see that this 5 are the results. Sorry, this is are the results of our docking process. So you just simply close it. You know this one is a 3.1 is the best one, right? You simply close it. And if you want to save the best one, just go to the files and this save PDB. Just select the best dock pose. This one is 14, and just by clicking control and just clicking here, select the best docking pose. I'm gonna name it as best. Okay, and it has to be in a single file. Relative model is our 14. Just click save. So here you got the best course. It is best dock. Here this is our complex of our protein of interest and a ligand. Ligand the best pose. That one has a lesser energy. Okay. What I am gonna do is I wanna explore it. I just want to know how it interacts with my protein. So I'm just opening it with Discord Studio, Bio Discord Studio. So sorry. Here you can see this is our ligand, right? This I'm gonna define it since it is undefined here. Just click this and define ligand. Okay. So from this, the Discover Studio knows this one is ligand and this one is protein. Let's go to the ligand interaction. It shows the ligand interaction with the receptor. Just click if you want to see whether it has an aromatic or hydrogen bond charges over here, hydrophobic interaction, ionizable, everything in this software is a good one. And just click the show 2D diagram. Yeah, here is the 2D representation of our interaction. Just click change the display size and I'm gonna enable the show distance so we can the distance of the one thing that's missing here. So, yeah, okay. Here you can see that our molecule has 3 conventional hydrogen bonds. Okay, that's great. And other pi-pi interactions, pi-pi T shape overlap, and other hydrophobic interaction with this. Okay, you dock the molecule using Chimera and AutoDock Vina. Okay. Here, if you just wish to get the best dock pose, just go here and here this one, the name and the PDB codified. This includes both all the poses of ligand. To get the best pose or review anything, just open the receptor. Open it with the Chimera. This one is the receptor, right? After that, just open the PDB kit view. Don't open the EST ligand. Just open the EST PDB kit view. Just click the PDP format. Okay. Here you get all the poses in it. This involves all poses, all sound poses. Just go to select and change the no ID. It shows all the poses. The first one is the good one, and we took that. If you want to analyze the second one too, just leave the second one and just delete everything here. And as I already told you, just go to save as a PDB. But if you want, just click this and your is right. Yeah, and click the post in which you want to analyze it. Okay, just click it and save it as I will just save it as EST2 response. Okay, just save it. Okay, that's it. Otherwise, you will get a bunch of this messy ligand over here. If you want one, you have to save it alone. Okay, so I'll just open it in the Bio Studio. This is the best post tool. Just closing it. Here, same. You have to define the ligand. You have to define. Once you define the ligand, just go to the interactions and the show 2D diagram. See here, it has only 2 hydrogen bonds and have a less potential energy. That's why it became as a second best pose. The first best pose, you can see that this one is the best dock. This is best pose. Here you can see that it has a 3 hydrogen interactions and more interactions compared to that. Okay, that's it.